3.27. It 4 plus 30 is.
I think you might have made a mistake on the first one, Steve. Okay, anyone. Anyway, everyone look up here. So we're going to go through number 1, guys. You haven't quite finished it. That's all right. Just follow along. So we know that T1 is 3 rather. T6 is 98. And we want to find T7. Yes? Yes, okay. I'm just going to shrinkify that a little bit. I know what my A is. It's 3. I don't know what my common difference is, though. But I do have a way of finding it. From T1 to T6, I just find the distance between them, so T6 minus T1, and I divide it by the jumps. T6 minus T1 is 98 minus 3 over, and from T1 to T6, how many jumps have I done? 95. 5. And that'll give us 95 divided by 5, which would be what? 19? Yeah, 19. Which will then give us our rule. Tn equals 3 plus 19 n minus 1. And what are we trying to find? T7. So let's just chuck n equals 7 into our rule. 117. Sounds right to me. We'll get to it.
Where did you get the 7 from?
7, we want term 7. Okay. Ready for number 2, guys? Who found that one all right? Yep, some thumbs up. Yep. Number 2 is a little bit trickier. No, actually, it's not trickier. It's the exact same level of trickiness. Sorry, I thought you started at term 4, but you know that the first term is 4. So, you know, T1 equals 4. T10 equals 30. So therefore, A is 4. Distance is just going to be 30 minus 4 over how many jumps? 9 jumps. 30 minus 4 is 26, so it's not gonna be an even number. 2.88, you reckon? So that means if we want to find T8, sorry, I'll do the whole rule first, sorry. Tn equals A plus D n minus 1. Tn equals 2.88 n minus 1. And therefore T8 equals 4 plus 2.88 8 minus 1. That's just the general rule. And then I subbed in, because I want to find the 8th term, so I just subbed in n equals 8. And what does that give us? Pretty easy. That one's just annoying because it had that decimal in it, but otherwise nothing harder than the first one. Okay. This one is very tricky. If I gave this to you on this exam, this would be a last question of the exam, complex unfamiliar. Yeah. So, do you agree, guys, that my terms are A, 2A, and then A squared? To get from A to 2A, what did I do? No. I added D. I added my common difference. What does my common difference have to be, though? Has to be A. Because I went from A to 2A. And then I added my common difference there again. So I can, from that, make the statement that, sorry, not A. My common difference is A.
Is that it? Just brilliant.
No, it asks to find the value of A. So I also know that A squared is the same thing as what?
Wait,
Sorry?
4A.
4A? You're on the right track, but not quite. If I start at A, how many times do I have to add the common difference to get to A squared? I have to add it twice, which gives me 3 altogether. So I start at A, I add the common difference twice, so I know that A squared has to equal 3A. If A times A equals 3 times A, what does A have to be? 3. Because if I got rid of the A from this right-hand side, divide by A, what's it leave me on the left? That is what, guys, I would call mostly a pure math problem. That has almost nothing to do with arithmetic sequences. You kind of need the arithmetic sequences to realize that it's going up by A each time. And 2A plus A equals A squared. Who looks at that and like, oh yeah, I kind of see what's going on there. That makes a bit of sense. Yeah. I'll straight up acknowledge it's a very different thing to say, oh yeah, that makes sense. And then if I gave you a different version of that to then be able to repeat it. But I want you to start looking at problems like this because there will be a problem similar to this where you need to really think about what's going on in the background to be able to solve it. As long as like I said, the only real trick, there's 2 here, is realizing the common difference is A, and then realizing that you can link A squared to something plus the common difference. And once you've done that, all your hard thinking is done. You just need to rearrange. As I say in physics all the time, this has ceased to be a physics problem. It's become a maths problem. But sort of like in maths, the version of that is sort of to say, this has stopped becoming an arithmetic sequences problem. It's become an algebra problem. And almost every problem we do at some stage stops being about whatever topic we're looking at, and it just becomes algebra. And that's going to continue to be the case for the next 2 years. Fun times. Let's get started with today. So we are looking at the sums of arithmetic sequences. So without using a calculator, who reckons they could add all the numbers from 1 to 100 in their head? You reckon? What do you reckon it is?
You
reckon it's about 1,000? Maybe.
No, it'll be like 750.
Someone a lot smarter than all of us was this guy called, sorry? Yep. Well, this guy, Gauss, if you study maths or science at uni, you're going to hear about Gauss all the time. He was a really famous scientist, mathematician. He invented a lot of ideas. But he got this exact problem in like high school. His teacher's like, he was doing it as like a mental maths problem. You need to add up all the numbers from 1 to 100. And everyone else is like sitting there writing down like, okay, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, going like that way. And the teacher said to old Carl over there, like, mate, how come you're not working? He's like, I figured it out. And he's just like, well, what is it then? And he rattled off the answer. And like, how did you do that? And what Gauss said is, well, if you're adding up all the numbers from 1 to 100, what if you add the 1 to the 100 and get 101? Then you add 2 to 99 and get 101. You add 3 to 98 and get 101. So that each pair is going to add up to 101. And then he just figured out how many pairs, 50. So he just did 50 times 99. And that's exactly what we're going to do for some of the series. So for some reasons that we'll look into as we go forward, sometimes if I give you an arithmetic sequence, you want to know how much, if you add up all the terms in the sequence, it's going to be. And it basically ends up, you just add the first number, the last number, and you times it by how many pairs there are. And that'll give you your answer. So yeah, so he solved the problem by realizing he could split numbers into 50 pairs, 101, 99, and 2, blah, blah, blah. 5,050. So there you go. So obviously, I'll be straight up, I never would have thought of that without reading it first, but this is why I'm not a famous mathematician or scientist with formulas named after me. So to find the sum of an arithmetic sequence, we call it a series. Well, no one else had invented it yet. So we call this a series. If I ask you to sum up like the first 10 terms of a series, that would be S10. So you know how we've said like find T10 before? Find the 10th value of the series? S10 means the sum of the first 10 values of the series. Sorry, that was bad handwriting even for me. So I swear that's not me doing cursive on purpose. I don't know what's going on here. S10 is it's trying to do cursive. I'm not doing this on purpose. Is the sum of the first 10 terms. So if we look at the example down below, guys, S6, the sum of the first 6 terms, we've got that there. Can you calculate that for me? What is S6? We're going to do this once manually just to show you that it sucks. And then after that, we're just always going to use the formula. But just put that in your calculators. Tell me what you get.
What's the topic of this code?
Series. Series. 160. You do that in your head. It's impressive. Okay, but let's say you wanted to then find for the same series, you wanted to find S72. Leave that to it. Well, even then, doing it in a calculator plus it would take you forever. Yeah, there's a formula. So the general rule, if we want to find the sum of a sequence, it'd be term 1 plus term 2 plus term 3, blah, 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 all the way up to term n, right? So do what Gauss did. We put them into pairs. So we've got term 1 and Tn, the first and last. Then we get second and second last, term 2 and Tn minus 1. And then you do third and third last, T3 and Tn minus. So because if you have a sequence where it's going up the same amount, the first number added to the last number is going to be the same as the second number added to the second last number. So like, because 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101, all the way until you get to, it would be 40, you divide it by like 0.5, so it would be, if you had 50 terms, you'd find what the first and last add up to, times it by 25. If you had 100 terms, times it by 50. If you had 1,000 terms, times it by 500. So you group up your first and last, second last, third last. Then you'll have, so for example, 1 to 100. In the middle, you'd have 50 by itself. No, you'd have 50 and 51, sorry. But if you went to 101, you would have a number in the middle by itself. But it works out, trust me. So this is our rule here, guys. The sum of n terms is equal to n over 2, bracket T1 plus Tn. There is a different version of this rule as well that I will show you too. So find the value of the following series. We're going to have to do some detective work to solve this one. Yeah. Well, actually, we won't. We will. We will, but we won't. When I see this word series, what does that tell me I'm finding? Yeah, the sum. If I said find the term, I just want the one individual. If I say series, I want them all. Oh, close. Formulas are on your formula book. So to use my formula, guys, Sn equals n over 2 t1 plus tn. Looks good, right? Sorry, bracket. Do we have all the information we need to solve that?
Yes.
I've heard both. Okay, let's go through one by one. Do we know n? What is it? No. We know what Sn is. Sorry, we know Tn rather. Tn is 122, but we don't know how many terms along that is. So we don't actually know n. But I do know T1 and Tn though. So I just need to find Tn. Sorry, n. So I'm going to go back to my arithmetic sequences to do this. I know we're going to do the working out. We're not doing this in our head. Yeah, we won't go into that today. If I write out my rule for an arithmetic sequence, guys, Tn equals a plus d bracket n minus 1. What am I going to put as Tn? 122, that's right. What's my first term? What's my common difference? So we just got to rearrange to get n by itself. Lachlan? Ooh. Ooh. Good point. It will be an error because I wrote this question, and I make errors all the time. Okay, let me think. So from 5 to 21 is a distance of 14, so it should be going up 7 each time. So that should be 13. So you just change that to 13, please, guys. Oh, wait, that's not right. 12, yeah. Sorry, I can't count. That should be 12. Wait, that's not right either. You know what?
What?
Oh no, 31 would work because then it's going up in 13s. Yeah, good point, Lachlan. 31. Good pickup. I'm going to throw this across the room soon. 31. Okay. And yeah, then it's going up in 13s. So to rearrange, minus 5 off both sides. Minus 5. So we get 1, 7. 117 equals. I have no clue why this is happening today. There must be 13 n minus 1. Okay. From there, divide both sides by 13. What's 117 divided by 13, guys? 9? And then just plus 1 to both sides. N equals 10. Okay. Now that we have n, do we have everything we need to solve the sum of the sequence? So to find the series, in other words. Yep, so S, and we want to find 10 equals 10 over 2 bracket 5 plus 122. So 5 times 127, and whatever that is our answer. Fair bit, yes. 635. Sounds reasonable to me. I am zen. No, so the sum, the way you would read this, guys, the sum of the first 10 terms is 635. That's all. So the sum of the first 10 terms is 635. Yes. term 1 plus term 2, 3, 4, 5, 6, 7, 8, 9, 10, 635. Cool. Let's flip over.
Then can you get that term?
Some questions I take from the textbook. Some questions, if I don't think the textbook explains it well enough to start with, I'll make my own. But generally, like in my head, I would have been like, okay, got by 13, 5, 18, and I just would have mistyped 21 instead of 31. On the next page, guys, I just want you to have a crack at them to start with. And we will go through them in a minute. So I'll just pause the recording.
I everyone.
Just thanks, guys. We're going to go through it up on the board. So can I have conversation ceased? Eyes up here. Still waiting. Thanks, guys. Okay, let's go through question 1 first. Okay, so the first thing we're going to do is you write out our rule, just figure out what we need, what we have. N over 2, and what is it? T1 plus Tn. Do I know what Sn is? No, that's what I'm going to solve for. That'd be a question mark. Do I know what N is? No, that'd be a question mark. Do I know what T1 is? Give it a tick. Do I know what Tn is? 25, sorry. 25. The last term in this sequence is 25. For those of you that didn't hear me say it before, if you ever see in maths plus ... plus, that ... just means the pattern continues. And because we can see the pattern is -4, that just means the pattern continues -4 until it gets to 25, and we're done. So we're just going to have to figure out n. So to do that, we need our arithmetic sequence rule. Tn equals a plus d n minus 1. If we sub in our known values, Tn is 25. A is 229. D is -4. To rearrange that, guys, -229 off both sides. A really common mistake, even in methods, guys, is people see the negative attached to the 4, and they're like, oh, it's -229. I'm going to plus it to both sides. You're going to end up getting the wrong answer, obviously, because that minus is attached to the 4, not to the 229. So what's 25 minus 229? -204 equals -4 n minus 1. Divide both sides by -4. What's that? 51. 51 equals n minus 1. So we then add 1 to both sides. N equals 52. Do we now have enough information to solve our Sn? We have one variable unknown still, but that's all right. In maths, we're allowed to have one variable unknown if we're solving, because that's what we're going to solve for. So Sn equals 52 over 2, 229 plus 25. And when you chuck that into the old calculator, what do you get? What? That's a very big number.
Yeah.
Oh, I meant the final answer.
Yeah.
What is it?
6604. Guys, this is a good habit actually to get into for methods. Once you have just numbers, don't worry about solving individual parts. Just put it all into your calculator. One of the biggest things that separates people that do really well and people that find it a bit harder is efficiency. So it's a good habit to try and be as efficient as possible. Anyway, let's keep going. So, how many terms of the following series need to be added to reach 495? Oh, this is different than one we solved before. What are we trying to solve for? Sorry?
How many terms? It's 12.
Yeah, how many terms? So we're solving for n. Solving for n. We know that Sn equals what?
Sn is
Uh-huh. Do I know what T1 is?
T1 is 80.
80. Do I know what Tn is? We kind of do.
What?
We kind of do. We don't know it exactly, but we can give we can say what it is. I know that Tn is 80 plus, what's my common difference? Minus 7. So let's make that minus 7. Bracket n minus 1.
And n is 495.
Sn is 495. Does what I've said there make sense, guys? That Tn is just 80 minus 7 and minus 1? That's just what we would do to find Tn if we knew what n was.
Why is this? I'll send today.
That's an equal sign. My thing just went crazy again. Definitely the thing going crazy, not my bad handwriting. Let's chuck this into a rule and see what we get. So we've got Sn equals n on 2, bracket, T1 plus Tn. Do I know what Sn is? Yep. Do I know what n is? No.
80 takes 7.
I do know what T1 is, and I kind of know what Tn is. Kind of. But you know when I said Tn is 80 minus 7 n minus 1, can you see that by writing it like that, I've turned it in, instead of just being an unknown Tn, I've made it an unknown using regular n? And if I use regular n in my rule, how many different unknowns do I have? Just one, because I'll have an n at the front and then I'll have an n in place of Tn. Yeah. And then that means the only thing that I have unknown is n. And I just have to solve for n then, which I can do. So let's sub in our known values. We've got 495 equals n on 2, bracket, 80 plus 80 minus 7, bracket n minus 1. Okay.
You 3 brackets.
3. Just 2. Pretend I closed that bracket properly. From there, guys, we just got to solve and simplify as much as we can. So I'm going to write 495 equals n over 2, bracket. I'm going to plus that 280s together, 160. And then I'm going to expand the 7 through the brackets. Minus 7n plus 7.
What?
Because negative 7 times negative 1 is positive 7. So I just did my negative 7 times the n, and then times the negative 1. And then I'll just clean that up one step further. Now, this is where we're going to cheat.
Also,
We could solve it that way. That's a really good pickup. We could actually solve this via quadratic formula. We're not going to solve it using quadratic formula. Can we get our graphics calculators, guys? Well, then you're just going to have to watch along. In your graphics calculators, can I get you to press the math button? So that one that's highlighted red on the screen right now. Math. And then I think it's right down the bottom. So if you go up and see where it says Be On Mine Solver, if you have the older ones like you do, it's a little bit different. I'll show you how to do it on your one. So Solver, enter. And it gives me two equations. Equation 1, equation 2. Sorry? Well, you practice it enough times and it becomes second nature. Math, solver. Equation 1 is going to be... Do you have the older version? I'll show you how to do this, then I'll look at anyone that doesn't have it working. Okay. Equation 1, guys, is just the left hand of the equal sign. So my equation 1 is 495. So I'm just going to put a note here. Use doesn't start with an E. Use G-Calc graphics calculator solver EQ1 equals 495 and EQ2 equals x on 2 bracket 167 minus 7 x close bracket. So what was my equation 1, guys? The left hand side of my brackets? 495. And equation 2, it was x on 2 times bracket 67 7x. And then this is where people mess up using the solver, guys. So really pay attention to this bit. If you click enter, it probably won't work properly for you. Can you see on my screen how it has the OK down the bottom there? The way you press OK is you actually use those grey buttons up the top. So you press this grey button graph. Take 167.
I know.
It should have been plus 7 because it was a negative times a negative. I just combined the 160. When I press it just solve x is 10. That means don't worry about that. We'll talk about that more later. Basically, if there's more than one answer, you have to tell the calculator where to guess. What the calculator does when it does this, by the way, is it, you know how I talked about us doing guess and check takes forever? The calculator can do like a million guess and checks at once. So it's checked numbers between negative, whatever, and millions. So it's guessed from like negative a million to a million. It's guessed as many times as it can, and it found the answer is exactly x equals 10. So n equals 10. Magic? I don't know. I'm not a programmer. So from that, n equals 10. Does that then solve the question? What was the question asking us to find? Sorry? No, we don't need to do anything now. We've solved it. It asks us how many terms of the following series need to add to reach 495. 10 do. That's it. Yeah. You can sub in 10 to the right-hand side, and you will get in an exam, I wouldn't expect you to check your answer unless it looked wrong. The reason I say that, looking at this, I would believe that 10 seems reasonable to me. If it said, if I got the answer like 508, I'd be like, that doesn't sound right. But 10 is about what I would have expected it to be anyway. How? Yeah, well, that's what I mean. Like, exactly. If you got an answer that wasn't reasonable, I'd sub it in just to check. And if it checked out, okay, good. My assumptions were wrong. If it doesn't check out, I've done something wrong mathematically. I remember this question now. Just question 3 sucks. We're not going to do it. You have to do it in parts, that's all, so I don't want to do it. It's not that helpful. And also, I went from talking about Brianna to talking about Mandy, so I obviously, wasn't on top of it when I wrote that one. $0. Because I find it a lot easier than,
How long did it take?
like, a while. I've done it over a long time. Like, I've taught this content for many years, so like I started one year like just taking the stuff I was doing in class anyway and putting it together. Guys, remember yesterday how I told you the wrong page? And then I fixed it and that was still the wrong page? The one I fixed it to was the right page for this stuff, so sequences. So, we have 15 minutes left. And I want you to go to, I think it was around 160 or 170. It wasn't 140.
150.
158?
Yes.
Yep. Can I get you to do... That is a 5.
Okay.
Question... 4, 10.
So, you left and right movement. No, I'm glad you.
4, 10, and 14.
Thank you. So left and
Are you
right.
looking for yours in particular? I may have grabbed it.
The name is?